Welcome to the Homelab Show, episode 31, File System Layouts. I'm here and with
Jay LaCroix.
Yes, this is one of those fundamental building block videos that maybe should have been done sooner. I don't know, but you're doing it now.
We're doing it now. That's all that matters. Better late than never.
Yeah, because this does come up from time to time, especially when you're loading Linux distros. Now, we're going to give some honorable mentions to some of the Windows file systems. But if anyone watched the most recent Linus Tech Tips video, he did remove his Windows storage spaces, and Windows storage spaces didn't scale to the large scale nature of some things. And once you get into the enterprise market or having a really extensible large scale file system, you'll find that Windows isn't dominant there. This is not what the cloud platforms run on. And if you're using Windows, it's not because you're choosing between which Windows platform file system you want. It's because you have to use Windows, you'll end up using the file system that Windows has. So it's not like, should I format my system with Windows or not? So we're not going to spend too much time on the Windows part of it. Mostly the question comes up about different file systems is ZFS, Btrfs, XFS, ext4. Should we be using LVM? Should we use MADM RAID or manage it with ZFS, which actually can talk to the hard drives, or Btrfs that can talk to the hard drives? And boy, we got a lot to talk about. How's that?
Yeah, we do. We really do. I feel like we could do like a series of like 30 episodes to go into the intricacies of each of the file systems. So we're going to summarize and bring up like the most important points of each of our talking points, and that'll help build the foundation.
Enough so you can make a decision. But of course, there is plenty of forums and debates and arguments over file systems over the years. And even me and Jay, when we were trying to get a couple updated pieces of information, you always got to check the year at each thing was written, because some of them, I mean, with ext2 versus 3 versus 4, yes, there's definite version changes, but some of the other ones, it's hard to tell what version they're talking about. They're just talking about ZFS or just talking about XFS. So there are features that have changed over time. So there'll be a lot to talk about here. But before we get started, we got to thank a sponsor of the show, and that is Linode. And probably Linode, I'm going to say, doesn't run NTFS in the background. What do you think, Jay?
I doubt it. I really doubt it.
Yeah. Being that they're a large Linux-based hosting, great place to hold your VMs. We've talked about a lot of projects on here. If you're listening to this podcast, it was downloaded from a Linode server, which is even faster. Since I was at episode 30, right before episode 30, Jay updated the memory, make it a little bit bigger and give us a little more bandwidth, because all of you keep downloading this podcast. And hey, we don't mind. Linode's providing the bandwidth is for it. Use it, click it, download it. We even make it just raw audio. If you don't want to use an app, you just want to listen to us raw. All that's available. And any of the projects, or many of the projects we've talked about in here, if you're looking for a place to run your servers, Linode is the place for that. It's where this website's hosted. It's where this podcast is hosted. And it's where Jay has, currently all of his public-facing stuff is all in Linode as well. So
everything.
Yeah. We want to thank Linode to be a sponsor. There is an offer code down below where you can get started yourself with Linode and, get playing, get some of those things out there. Use some of those predefined templates so you don't have to build it from scratch, so you can test it out, or then learn how to build it from scratch and things like that. Use the pre-built ones as a reference, because I've done that a lot, man. I don't know why something doesn't work when I build it, but it works when I click the one-click button, and good ways to troubleshoot it. So thanks again for Linode for sponsoring the show, and let's dive into file systems.
Let's get into it.
What's the first one we want to talk about, Jay?
So I don't really mind the order, because I know we need to talk about LVM, which isn't itself a file system, but it's definitely a talking point. But we should probably save that for a little bit later, and maybe possibly go over ext4 first, because it's the default on many distributions out there.
Yeah, ext4 is the 4th generation of the ext file system. Now, the one thing I like about ext, and I think it's 100% backwards all the way, is you can import previous versions of ext into the upgrade version. I believe all of them can do in-place upgrades. Is that correct, Jay?
I think so. I haven't done that in so many years. I know that was it ext2 to ext3 you converted by just adding journaling, I believe.
Yeah.
I believe, yeah. So that was kind of like an interesting upgrade. It's like adding the feature there. But it's been so long since I've had to upgrade anything from ext3 to ext4. I want to say, what was it, like 2008?
Yeah.
or 9 or something like that.
But it's unfortunate because there are some really old systems out there. And so ext through all of its generations has become a much more robust file system. The way they distribute the journals on there, journals, think of them, it's all that data around where your data is, and they spread them out across the drive. This isn't, I mean, we could dive through, and who we need is maybe we'll get Wendell to dive through the file system history with us. Maybe we'll do an episode on that, in the history of fat file systems and how things were written to drives. And things were adapted in early days of Linux and Unix with the basic file systems. And someone says, that's not the best way to do it. Hard drives are getting better. And they added these journaling support to be able to have a journal of the transactions that occurred. This makes recovery easier. Corrupted file systems was a big thing. And you'll talk to older technicians that go, oh man, there's so much risk of corruption. It's actually such a minor issue in 2021 because of the robustness added for things like the extra journals and the way they spread them out across ext4. ext4 is a pretty solid file system. It is a default, I think, for Debian and all Debian based distributions. Am I right, Jay? Pretty much all of them follow that pattern, right?
I would say the majority. I mean, you have Btrfs for, I believe it's OpenSUSE and possibly Fedora. It's like I review so many distributions that it kind of starts to blend in after a while. But most of the distributions out there default to ext4. I like to think of ext4 as the general purpose Linux file system, because if you don't have a preference, just go with that.
Yeah, it works fine. It has all the features you need of a modern file system, so there's not any reason to not use it. It's solid, it's reliable. It does not, though, and some of the other ones we get into, it does not support any type of snapshots. This is a contention point. Now, when we get an LVM, there's a way you can snapshot ext4 with LVM, correct, Jay? We'll get to that a little bit later.
Oh, yeah, we will.
But it's not a function of the ext4 file system itself. And let's talk about the other one. If you are over on the other side and you're wearing a red hat, what type of file system would be the default over there?
So I know haven't used Red Hat in a while, so I'm thinking, was it XFS? So it's a bit of a trivia. So I guess it's a guess.
Yes, XFS is really popular. You'll find most of the documentation over there on the website for Red Hat. Now, XFS addressed issues when it came out against ext. And when I say when it came out, that was like 30 plus years ago. So they've been both developed. They're both long time stable file systems. And with XFS, there's also no snapshots natively built in there. And it's basically just Red Hat prefers using it. There are some performance arguments of which one supports more directories versus which one supports more files in it. There's lots of little nuance, but we're talking like massive things that any home user was never going to run into. It's only something you would think about on the cloud level scale of a massive system, but both these have advantages. Now, XFS seems to suffer a little bit more from small write issues, but these are often contested in different tuning parameters. I was reading through benchmarks to try to get a definitive. It is not like there's a night and day difference. There is a nuanced difference depending on the workload. It seems that the XFS seems to handle some of the larger files. So Red Hat uses it because they recommend it for like databases and things like that. So there's a little nuance in there. So it's still a good choice. It still works perfectly fine. And for most all your production environment, whether you're going ext4 or XFS, I think is it's a flip the coin. What are you most familiar with? What are you most comfortable using? And are you using Red Hat? And it defaulted that anyways.
Right. That's a good point. And I think it all comes down to what your use case is, because if there was a clear winner, like the podcast would be like 5 minutes long. We would say, just use this one and we're done. But we can't say that because there's so many pros and cons. And sometimes it comes down to the workload. If it's like a database server, maybe one will work better for the other. Maybe, large files, if you have like ebabytes, I don't know if I'm saying that right, of data, like, one will be better for that. But I mean, if you have that much data, like, congratulations, that's amazing.
Yeah. And I don't really imagine too many people, when you look at the maximum supported single volume size of ext4 or a XFS system, I don't really imagine a lot of people are creating single volume sizes like that, because when we get into ZFS, anytime we see these incredibly large systems, ZFS is kind of the king of all that. So we're spending a little more time talking about ZFS, but yeah, once you get into, right now we have 1.2 petabyte servers on the shelf on the other room over in there, getting ready for a client project delivery next month. And, that's always going to be ZFS for that type of storage. So is there existing storage that's that big?
Yep. So I think at this point, it's probably a good time to get into LVM because I think some of the things we're going to talk about are going to kind of force a comparison
Yeah.
there. And LVM is not a file system. I want to be clear on that. It's like an abstraction, underneath the file system. That's after the hard drive, beneath the file system. That gives you additional features. And it's one of those things that I say everybody should be using. I mean, if you're not using ZFS, if you're not using Btrfs, I don't know if it works with Btrfs. I haven't tried it, but not with ZFS though. If you're not using that, then I think that LVM is a no-brainer because it's one of those things where you're not going to notice that it's there, and maybe you'll use it and you'll never have a use for its features, but it's not going to hurt anything. And if you ever do need its features, then it's there for you. What are the features? So one of the things that is kind of a pain point for me is when I'm working with a client, companies ask me to help them out with their servers, right? So their server's full, their disk is completely full. Let's just assume it's a virtual machine. So if without LVM, you have to rsync the volume to another volume if it's not the root file system, and you add another virtual disk and you rsync everything over there and then flip the mount point over to it. There's going to be maybe a disconnect there. You're going to have open files, for example. It's not going to be very easy to do this, but you can do it. In worst case scenario, if it's the root file system, you might have to shut it down, and that's not good. Now, obviously, if you're doing everything right, you should never need to resize anything because you've chose the right size for everything. Your virtual disks are the perfect size. You don't ever need to upgrade anything. So if you're doing it right, you'll never need it. But more often than not, you're going to run into this. And I think as an administrator, you're going to appreciate having the ability to resize a file system online. So for example, you have let's just say a 100 gig root file system, and it's nearly full. Now, what you could do is add a second virtual disk, add it to the volume group, and then expand it. You can actually grow it online, and you don't have to restart anything. And all of a sudden, your full disk alerts go away. It's a great thing. On a physical server, it's not quite as easy because depending on the hardware, you may not be able to hot plug a hard drive into a running server. You might actually have to shut it down. But if you have a spare hard drive, you could just have it connected inside the chassis, powered on, but just not used. So if nothing else, you can always add it to the volume group later. I've even seen some people that would essentially not use up all of the space in the LVM configuration, have 10, 20 gigabytes that are not even claimed for that one-off, oh my God, I need space because everything is falling over. But to kind of go back a little bit, we got to talk about what LVM actually is because I just talked about the benefits. So if you think of LVM, it's more or less an abstraction on top of the hard drive. It isn't itself a file system. You can use LVM with ext4, XFS, whatever you want. So you have different terms with LVM, which stands for Logical Volume Manager, that are kind of like these, I think they're hard for some beginners to remember, especially considering one of the terms is physical volume. And when you think of physical volume, you're thinking about a hard drive you can hold in your hand. That's a physical volume. You have a physical disk in your hand, right? But with a physical volume in LVM is not that. It's just a disk. It could be a virtual disk. It could be a physical disk. It doesn't really matter. So when you create a physical volume, you are basically saying this hard drive is a physical volume. It's going to be used entirely for LVM. Then what you do is you create a volume group. You could have multiple volume groups that group together logical volumes. Logical volumes is closer to a partition. So you have a physical volume, you have a volume group, and then you have a logical volume, which you could then format. So you could basically have your root file system as a logical volume, home partition, logical volume, and you could keep going and have as many as you need there. And the cool thing about that is you can resize them and grow them independently of each other. So if you have extra space not used up, that's not claimed by logical volume, you could actually just go ahead and expand it. And that ability may not be as useful to a Homelab person because, let's be honest, if your server's full, are you going to have a bunch of people coming into your office and complaining about it? I mean, the worst case scenario, your kids say, hey, the Plex server's not working. Could you fix it? But it's still kind of cool to have. And there's no reason not to implement it because, again, if you don't ever run into that situation, it's just silently running there in the background. And it's a great thing. And you could also create logical volumes on the fly. You don't have to shut down the server. You can actually create a new one. If you have space, mount it, you're done. But another feature I like is the ability for snapshots. Now, this is something that I think it's safe to say, let me know if you agree, that the majority of file systems out there don't have snapshot features. And I feel like snapshot features in a file system is more or less it's just a value add that some of them have, but it's not something you generally find in file systems. ZFS has it, Btrfs has it. But I would argue that Btrfs and ZFS are more than just a file system. It's almost like a file system solution application hybrid, if you will, in many ways. But a pure file system is just, blocks and whatnot, how you store data, and that's really it. Now, with LVM, you can create snapshots. And one of the things that really annoys me is that when you use, let's just say Ubuntu, for example, and you're installing it, and you say, I want LVM, it's going to use 100% of your disk, period, 100% used. So when you want to create a snapshot, you can't because there's no room. Snapshots with LVM require some extra space that's not used by a volume group, or basically free space in the volume group for the you're not formatting the snapshot. Your snapshot is just sitting in the unused space. When you install Ubuntu, you don't have unused space because it uses 100% of everything, which is annoying because if you want to use that, then you have to use a partition tool to basically create a volume group and set it up yourself before Ubuntu is installed. And then you just point Ubuntu to the partitions that you've already created that works. I think that's one edge that the Debian installer has over Ubuntu, because with Debian, you could tell it, don't use the entire disk for LVM. Give me some, unused space at the end there so I could use that if I need it later. Debian lets you do that. And I think that's really cool because then you could do snapshots. Snapshots are, I guess, in LVM, something you want to try to use only when you need to. You don't want to have a snapshot sitting there because if it uses up all the space, bad things will happen. Yeah. Snapshots are temporary. You want to test out a piece of software, create a snapshot, test out the software. I don't like that software. It doesn't work for me. Revert the snapshot back, and then it's like nothing ever happened. Leave that snapshot hanging out there. It's going to use up a bunch of space, and it's just not going to be good. So basically, you want to keep your eye on that. But one use case I like snapshots for is Arch Linux. It's like the ultimate way to run Arch because Arch is rolling all the time. You have updates every single day. So what happens if you have an update that breaks something? It does happen, happens to me sometimes. If you take an LVM snapshot before you run your updates, no problem. If something's break, some things break, you just revert the snapshot back. It's like nothing ever happened. Wait a couple of days, try the update again, see if it works. If it does, make the snapshot permanent, just get rid of it. It's good, everything's fine. And then you have a greater level of stability on top of Arch Linux than you would get normally, which is kind of like the secret sauce, I think, with rolling distros. Just create a snapshot before you update anything. It's like the best, the best thing ever.
You can quickly revert back. I think a couple things I've seen this in the comments, and it's something I want to address is, let's say I have a drive and I ran out of space and I want to expand, not add another volume group, expand the main volume with LVM. So I pop another drive and I expand it. Where's the data? It's spread across 2 drives. If I lose one of those, I've lost it all. Am I correct?
Yeah. I mean, that's kind of, it kind of also depends on how you set it up, because one question I get asked sometimes is like RAID with MDADM versus LVM. You can't compare the two because one's a RAID solution, one's a file system abstraction. But I personally, I think I might have once set up MDADM RAID, software RAID in Linux, if you will, manually, never again. What I always do is I set up, LVM with Debian or Ubuntu, and then of course we have MDADM underneath, and then you have LVM on top. So you have your RAID, and then LVM is how you split the partitions out. So in that situation, when you have RAID, I mean, already you have a situation where if it's like RAID 0, you lose a disk, you lose data. But if it's RAID plus LVM, depending on the type of RAID that you set it up with, RAID 5, RAID 6, for example, I always prefer 6, but that's just me. You could lose a couple of drives and you're fine. But if you have straight LVM with no RAID at all, you can't lose a disk because it's part of the volume group. That bad things will happen. And I've seen junior Linux admins make this mistake where they try to snapshot a virtual machine, and just habitually they snapshot the main disk and nothing works. Oh, there's another disk. They should have snapshotted all of the virtual disks, because maybe they have that one-off client that's using multiple disks or whatnot. So you have to take that into consideration. When you have LVM, all the disks are part of a whole. If you take one out, there's a problem. And I think the only way you can get away with losing a disk is if you combine it with RAID.
Yeah, and something else worth mentioning is the way when you set up, let's say, a Debian system, you want to have a password on boot, and this works with Ubuntu as well. I believe it sets it up with a LVM and Lux encryption, so you got a small boot partition where it can load the kernel, and then it prompts you for the password. You can configure this to have different volume groups locked. That way, if someone ever takes the drive, they have to have a password in order to boot this system up. They have to have that Lux password you set, so there's no way for people to get the data off the drive. It puts the splits it up. And you can even, maybe you want the system to boot at least to a level where you can remote into it, so you let it boot, but then it has another volume group where your important things are, and then you have to unlock that volume group with a password. So there's a couple different strategies by which you can deal with that.
Yeah, and you can have a Lux encrypted drive without LVM. But when you are installing like Ubuntu and you choose that option for encryption, full disk encryption, it only gives you the option with LVM. I mean, even though you could separate the two, I mean, why separate the two, honestly? Like, just use LVM. One other thing I'll mention about LVM, like I think I've alluded to it, I've mentioned already, use it on everything. Absolutely use LVM on everything, because when you are, for example, working in a company, if you do that, and you have a server that's mission critical and it has LVM, you're going to feel like a hero, like a rock star, when you are able to solve that full disk problem without the server going down, without losing any pings. All of a sudden it goes from 0% free space to 30%, depending on how much you give it. It's just so awesome. And it's so much more frustrating to have to plan a maintenance window to shut it down because somebody didn't use LVM at the beginning. Of course, I'm talking about the enterprise here, but yeah, it may not be that big of a benefit for the Homelab user, but I still think it's cool. And if you don't have to reboot it, why, right? Just use LVM, and if you need it, it's there. I make it the default on everything I do.
Well, there's also an advantage when you're doing this. It makes it a little bit simpler when you're running virtual machines. So if you build your virtual machine and you set it up with LVM, and you're like, oh, I need to add more space to the virtual machine. Shut the virtual machine down, expand the hard drive. Easy. Or if it's iSCSI, you can do it that way. Less easy, well, just more steps, is now how do you expand it if you didn't have LVM? There's a few more steps. Not that you can't. There's just more steps in it. But the steps are shut it down, expand the size, boot it up, run the proper LVM commands to expand it. You had the absolute most minimal amount of downtime to actually make that happen. And I will add in, and we'll leave it a link in the show notes for this. You have a whole series on LVM, do you not, Jay?
I do. Actually, it's an all-in-one video. That's
okay, perfect.
Like an all-in-one video guide. You don't even have to have multiple versions. It's just one video and you learn everything.
Yeah. So we'll have we'll make sure we have that in the show notes. That way you can just dive into LVM and learn about it. I got to watch it again. I don't do enough with LVM because at least I usually, so far my planning has been, hey, it's the right size, so I don't need to do much, but it's definitely a concern.
Yes, it is. Another thing that I think I'd be remiss if I didn't mention this, you can actually reduce instead of enlarge. So if you have your, LVM is using up your entire disk, you can actually reduce and, shrink that down to where you could get free space back. I don't ever recommend anyone does that. Some file systems absolutely supports reducing and shrinking volume sizes, but I've still run into problems. I don't know why. XFS has historically been one of the worst when it comes to reducing a logical volume. In pretty much you can't, although I have seen some patches and improvements that claim that you can now, but I've still not seen it work. And even with ext4, one time I reduced it and the whole system wouldn't boot anymore. Even technically you can reduce, but just don't. Start small and then go up. If you have like a 500 gig disk, for example, give it 400 gigs for the physical volume, the volume group, just leave 100 gigs unused. So you have that space to play with if you need it, and some room to, oh my God, I need space right now. Okay, you have some space that's just sitting there waiting to be used, and you're fine. Just don't go down, just go up.
Yep. Keep your life simple like that.
Yep.
All right. Where's the next one we should jump into?
So now that we have LVM out of the way, we do have Riser-FS on our list as well, if you want to talk about that.
Yeah, I just want to give the brief history. This was an interesting one if you want to go through the history of things. The Btrfs was really an innovative and interesting file system written by a pretty small team. It has a more tragic history of what happened to one of the developers, which you'll find when you start reading on there. But
yeah,
this was the first time, and I want to bring it up in here because it was the first time I ran into writing a piece of backup software years and years ago in the early days of Linux. I said, I can design this whole system to back up all these client computers. And I ran into some of the limitations. Back then it would have been ext3 because this was circa 2004 when I wrote this. But that was one of the things that it's kind of interesting when you start running to with the scalability of file systems. And I thought I'd preface it with just mentioning, because it's a fun dive into the history of what that problem went out to solve and how we ended up with both Btrfs and ZFS. ZFS being, as we mentioned, the king of all of this. And I just wanted to bring that a little bit of history up. I think it's an interesting dive, as I'm a big nerd when it comes to the history of computer and technology, just like Jay, as we get on these discussions like we did last night about the history of some of this stuff.
We do,
It just really gets an interesting mention because it was a really clever and innovative file system. Unfortunately, with the tragedy and related to the developer of that, well, the primary lead developer, that kind of fell apart on there. So it's also an interesting of what happens when a project falls apart, doesn't have a lead developer, and kind of goes stale. Now, now that we mentioned that, I think we talked a little about MDAM. I'm saying it wrong.
It's so hard. MDADM. We could just say MD RAID.
MD RAID. There we go. Yeah. So Tom doesn't say it wrong. The one thing I'll mention with MD RAID is that is just a system by which it's going to manage the hard drives. And I wanted to mention it because that's very different than the way ZFS works or the way Btrfs can work. Now, I'm much less an expert on Btrfs, but with ZFS isn't just a file system with a lot of features. It's also directly talking to the hard drives to format them. The way, if you wanted to build a RAID array with ext4 or LVM and then ext4 under it or XFS under it, is first you would physically link all the drives together with the Linux RAID utility. Then once it creates this new logical block device here, this block device then gets the file system added to it. This is one step in ZFS. And this is where I'm dive a little bit into ZFS here. ZFS is the billion-dollar file system, as quoted many times by Wendell and a few other people. We've actually been trying to find the exact developer. I want to get him. I want to get a clip of him saying it so I can just insert him. It's because of the years of development. It's kind of just one of those marketing terms in some ways, but it's when that many large-scale enterprise companies have worked on it for that many years. That's the kind of money that's been spent on really fine-tuning and engineering. Now, the reason it was unpopular in Linux is because Oracle is known for one thing more than any other, and it's not actually Java, it's lawyers. Right. If there's something Oracle is known for, it's being litigious. So there was obviously concerns because Oracle bought the rights for ZFS when they acquired some of the other assets they've acquired. But either way, that created some licensing issues and things like that. Now, ZFS was still a great system, but the licensing around Oracle created a lot of drama. So this kept it out of the Linux market, but it was compatible with the FreeBSD licensing. Q years forward, and thanks to a popular product we've talked about here, TrueNAS, and this is actually the parent company. IX Systems is a big sponsor and employs quite a few people working on this. This brings us all the way around to a system that works much better and has a better license compatibility with the modern versions of like OpenZFS. It's stable and things like that. That's why we're starting to see it finally get into the Linux world as opposed to just the BSD world, because now there's not that fear of the giant gorilla in the room that is Oracle and the litigious nature of that company. They're just not friendly. No one likes them. Ask Google what they think of them. It's like watching them duke it out over licensing. I think they employ more lawyers than developers, honestly. But anyways.
Yeah, I almost feel like you could create a Netflix TV show with all this drama that goes in the background and suing and intellectual property and all that. It's so many things. And I think that Red Hat still is kind of afraid of ZFS in a way. I don't know if they've actually said that openly, but I mean, the fear might be that Red Hat being such a bigger company that they'd be a bigger target for lawsuits. Would they go after a smaller distro? Probably not as much as they would go after one of the bigger companies. Of course, that is all just my opinion based on no facts, just kind of what I've observed, but it does kind of seem to be the case.
Yeah. So it's one of those things, and that's not to get too far into the legal history of it, but a lot of times what these companies do, Oracle definitely included, is they sue the largest company because they want to set a precedence, or sometimes the second largest. They try to find someone they can set a case precedence with, because if one individual developing some distro, or even a small team of them, maybe they could send a decent desist, but no one would think a whole lot of it, and they probably wouldn't have the resources to fight it. So when they try to set their sights on certain ones, it's just that case precedence. But back over to the point, file systems and ZFS. So now that we're starting to see ZFS on Linux, Q, the latest version of TrueNAS Scale, just hit release candidate the other day. But ZFS is one, a way to manage the drives directly. So you take the drives and you put ZFS on the drives, not an adjacent file system, not anything else. It is a file system format at that level. So because ZFS is talking to the hard drives, this gives a lot more control over the developers for the extra features they want to add, because you're getting to control things at a block level. This is why things like ZFS send, where you duplicate a data set from one ZFS pool to another, it doesn't even care if there's a million files or 2 files. It doesn't matter. It always looks at everything from the block. Jeff from Craft Computing actually just did a video on deduplication. The reason it works so well and the way you can deduplicate data on ZFS is, once again, it's operating at that block level. So this is another great feature. So if you have duplicate sets of data, it is able to create deduplication tables to say, nope, that's the same data. It may have 2 different file names. We know the data and the block level that it works at. This is some huge advantage for companies who go, well, sometimes we do have duplicated data across clients, but we can't have the clients seeing each other. But we can create deduplication where that data can reside there. There are so many things. We could probably do an entire video, once again, on just ZFS, because there's so many things. Now, snapshots, that's another feature that ZFS has that's outstanding. It's very granular, and on the fly, you can just restore a snapshot and have things instantly reverted back and forth with granular control of how you want to do that. Block sizes, how you write the data to the drives matters. How you write the data to a data set matters. And there are, when you're dealing with a singular volume in ext4, well, setting the block size per folder, that doesn't make sense. That's not something it can do. ZFS can. This is where, if you have something that's going to do a series of small write transactions, it would be better to set them to a smaller block size that matches the commit size of the database transactions. But that same ZFS volume can have another data set that's optimized for, let's say, video editing, where there's larger chunks, and it would benefit more from a larger commit for the way that does. This is one of the reasons ZFS is so used, and the scalability of all of it. You're talking about a file system that can grow absolutely to maddening scale. I forget exactly what the upper limit is for it at the moment, but it's absolutely why it's used in enterprise and cloud environments quite frequently, because of its scalability. And someone may bring up something like CephFS. I don't know why I have a hard time saying it, but these actually run in the background on ZFS. And if you can check out 45 Drives, has a whole series on Ceph to kind of get a better understanding of some of those things that goes outside the file system type. Swinging it back over to ZFS, there's also the ability with ZFS to add, besides the drives you have that store your data, what are referred to as data VDEVs, ZFS also has that advantage of adding things like metadata or caching VDEVs or deduplication VDEVs. These extra files, these extra drive types that are attached to the file system, it kind of gives you hardware level features that you're adding to a file system that is then presented as just a place you store your data, but all the behind the scenes can be delegated out to the most optimized devices on there. So as much as we thought here in 2021 spinning Rust would be a thing of the past, it turns out they're really good at keep re-engineering spinning Rust drives to make them bigger. But these small SSDs might be better for certain caching functions, metadata functions, or the deduplication table functions. And this is one of the reasons ZFS, because it can do all of these things and more than we have time to cover in this podcast, it's one of the reasons it's such a popular file system and such a great choice. But it's only more recently that you can really see things like installers with ZFS built into Linux. Have you tried any of them, Jay?
I have, and Ubuntu, I think they still kind of consider it beta, even though it's kind of not. I'm hoping that with the next release of Ubuntu, the next LTS, they'll take the beta term off of it. But the desktop installer, server installer gives you that ability. I have to be honest, though, I think I'm a little bit mixed about this because when it comes to a server, it's a no-brainer. Use ZFS. I mean, that's a great thing.
Yeah.
But when it comes to your laptop or desktop, I'm not really so sure. Like, I don't know how you feel about this. I know that the ZFS cache has to come into play here, and that you're kind of losing more of your RAM. Maybe not that much. Maybe they've adjusted it to make it work in a sane way. But it kind of just seems like overkill on desktops and laptops. But I know a lot of people are really wanting to use it there. So I don't know if you have an opinion on that. But I
Ah,
don't think I've noticed a big decrease in performance. But then again, I have really good laptops too. So I'm not really sure if I'd recommend it there. Also, when it comes to Proxmox, so far I have not had a good experience with ZFS and Proxmox. I don't think that there's anything wrong with ZFS. I think it's just how it's implemented, where I would go to see how much memory I have free. Oh, I have 40, 50% memory free. I'm good to set up another VM. Wait a minute, why is it crashing? Oh, because the memory that is telling me that I have free, I don't actually have free. And then next thing you know, VMs start falling over. Um, there's definitely probably a way to better tune that. I think I've done that in the past. So on Linux, I feel like it can kind of be depending on the context and what you're using it on, but on TrueNAS, it's just so great. Like it's just such a win overall.
yeah. As far as running it on the desktop, there are some goods and bads. One, all that complexity I talk about, cool if you need that level of complexity on your desktop. Performance wise, well, out of the box, you're going to have things like sync turned on. That may not be the most optimal way you want to set up for performance on there. That's a problem. Memory isn't expensive, but it's the way it becomes implemented because ZFS on Linux is fairly new. Hence the reason they still have like the beta tag on it for Ubuntu. Figuring out and tuning how much memory you need allocated to ZFS. ZFS, by its default nature, says, hey, if you've asked for this file once, you might ask for it again. So let me hold this much in memory. And ZFS, if there's free memory, ZFS likes to grab that free memory and put things there. I mean, you're not using it. And this is the way it works over in TrueNAS. If there's free memory, it's going to use that free memory to cache files. This is why it works so well for TrueNAS, because what else are you going to do with the memory unless you've allocated it to maybe some different jails you have running there, or in the case of TrueNAS Scale, some different containers that you've got running in Docker. Unless you've allocated to other resources, it'll use the memory for that. This becomes a little bit trickier on a desktop or laptop environment. You're going to have a different set of parameters. And do you really need all that cool features that ZFS has? That's kind of going to be a personal choice on there. And there is, no matter what, once you start talking about adding the complexities of ZFS, no matter how much they tune it, well, that copy on write file system type of journaling that it does have a little bit of overhead on it. So there is not going to be necessarily a one-to-one performance with ext4 because it has that extra data. It has to be written, verified, and synced along with all the other complexities on there. There's more code to run through. So when that happens, there is just more to do to ensure the integrity of the data, which is amazing and save you from things like bit rot. But is bit rot even a concern on a desktop or a laptop? It's something you really want to focus on your NAS. So it's kind of up to you. I don't see a reason truly not to run it, but if you're trying to get the most performance out of your hard drive and you're only a single drive, and as I said, ZFS rates the drive, or mostly when people have arrays of drives, if you're not building an array of drives in your desktop, I have a harder time justifying the use case. And that's one of the reasons for me, I'll still use the default file system. I mean, when it comes out, I'll do testing with it because I'm kind of excited. Maybe I'll test a server with it, but it's not as likely to become the native thing I format it with when I build these.
Yeah, I agree. I almost wonder if they intelligently control what's being cached. If we could get into a situation where the entire desktop environment is cached and your most common apps that you use are all cached in RAM, to increase performance that way would be pretty sweet if they go that direction, but one can only hope, I guess.
Yeah. So and someone pointed out, and they're right about this. The native default, if you're running a ZFS on Linux, is to only take up to 50% max of memory, not 100% like it is in BSD. But that is a system tunable feature. You can, that's obviously something that's going to go a step further. Certain distros may tune it differently than other distros. So that's the default from prescribed by the standard, but people, follow standards. What? We're writing our own distro. We got our own ideas of how things should be done.
Yep, we have our own ideas for sure.
Yeah. So that's kind of, like I said, without spending the entire episode talking about ZFS, that's what it is. And it's, as I mentioned briefly, copy on write. This is one of the final integrity checks, is there's always a copy of your data, and on write, we confirm it, we commit it, we sync it. Copy on write means there's always an extra journal of your data. Part of that integrity checking is ZFS. And of course, ZFS is handling if you have multiple drives, so parity checking on there. And let's swing it over to the world of Btrfs. Now, I admit me and Jay both read some on here. Neither one of us will at all claim to be Btrfs experts. Btrfs is also a copy on write file system. My feeling is that Btrfs was really pushed because ZFS and the Oracle debacle for years. Btrfs has been around a little while. Btrfs has also got the ability to, but from anything I've talked to people that seem to be knowledgeable on this subject, they don't recommend necessarily having Btrfs directly manage the drives. Let me give you a great example of a company I've talked to about this, Synology. Synology chooses to use the Linux RAID tool to manage the drives, but then once they manage the drives with the RAID tool, the MDADM tool, from there, the volume it creates gives you the option to ext4 or Btrfs. Btrfs gets you all these cool checksum, self-healing features, journal features. It's a copy on write file system. And it seems like most of the complaints people have, like for stability in regards to Btrfs, seem to relate to the Btrfs directly controlling the drives, which is what the Synology has chose to say, nope, that's why we don't have Btrfs controlling the drives. We control the drives with the tried and true Linux RAID tools. We've optimized for it in the Synology product line. And Synology's not the only one, by the way. My understanding is there's quite a few other NAS vendors out there that do the same thing. They use the Linux base kernel. They use MDADM RAID to control the drives at the physical layer. And then that creates a logical block device that you then can choose to format with Btrfs. And Btrfs does have snapshots, does have a lot of features, and Synology's done a lot of nice integration into it, as have many other companies. So it allows that extra feature set on there. I don't think Btrfs is necessarily that bad under that context. As long as it's not directly controlling the drives, it seems to be a pretty robust operating system. But without large scale popularity, you run into misconceptions, you run into maybe less knowledge from developers implementing it. So there can be bad implementations of it out there from less experienced developers, which can also lead to, and there's much less documentation on it compared to ZFS in terms of years of use because of companies like TrueNAS pushing ZFS. So it becomes a little bit harder to really work on and understand. And I don't know that it has all the same ZFS send features and all the extra drive VDEV types that you support in ZFS. So it's good. It's still a good system. It's not a reason not to use it, but I don't know that honestly, because now with the choices with Open ZFS, I don't really feel the future of Btrfs. When you talk about Ubuntu pushing ZFS, I'm going to say I don't see the really bright and shiny future for it. That's my opinion as Lawrence, by the way.
Well, I mean, my opinion is similar. I think that I could see OpenZFS being the default for pretty much every server-related thing at one point in the future. I don't know how far from now. Maybe Btrfs for the desktop, because I think it's probably better for that anyway, because I don't think it's going to have as much overhead. I feel like there's a reputation problem, and I've noticed that, this in the Linux community, that reputation is everything, and that's true of most things, but even more so in Linux. Like, if you get a bad reputation in Linux, it sticks for many years. I mean, I don't even know how long ago it was that Linux Mint had that big problem where someone got into their database server and they had some bad ISO images that were made available for download. That was a really long time ago. People still talk about it. A long time ago, Ubuntu had the Amazon shopping thing in the Unity dash. They don't even use Unity anymore, and people are still talking about that. So in terms of Btrfs, I think what I remember happening is that they declared it stable too soon. And it's not just Btrfs, it's not their fault necessarily, because a lot of the tools like DF and all those standard tools for disk storage wasn't patched for Btrfs yet. So people weren't even getting like an accurate representation of how much space they actually had free. And then they would blame Btrfs for that. Does Btrfs have problems? Well, yes, it does. But now that some people have had problems and people started complaining about it on account of the fact that they declared it stable too soon, I kind of feel like that caused it to really not be as adopted as widely as it could have. And I almost wonder if like developers kind of abandon it, like the volunteer developers abandon it, because if it has a bad reputation, why am I developing for this thing that everybody seems to hate? And then because there's not enough people developing on it, the progress slows down. So I feel like in a lot of ways, Btrfs was kind of like a victim.
Yeah.
And yeah, there are rough edges, like you brought up. There always is, but I almost wonder if like we'd be past all of that now if it wasn't for that declaration of 1.0 that they made prematurely.
Yeah. And like I said, I'm not saying it's a dead project at all, by far not dead. It's just when I look at the 20-year down the road future, not like the next 5 or 10 years,
Right.
I don't see as many people, like I said, with the excitement here. But then again, there's a new file system under development right now. I don't know what even it's called, but I guarantee someone's doing it. And that could be what we're using 5 years from now because someone just figured out something better. You look at any new technology, if it's really well written and just solves all the problems, but then becomes a simpler code base. And we'll use
Right.
like the excitement around WireGuard. Look how fast WireGuard became popular. Now it's still not the drop-in solution for everything, but a lot of tooling was built around it very quickly because they're like, hey, that's a really clever way to solve a problem with VPN. We may have someone working right now or some small team that just has the next answer to the file system. Right now, I think that's still ZFS, but hey, the world does change. So that's also,
Yep.
if you listen to this podcast, and just a reminder, it is 2021. So you can do
Right.
this 5 years from now. Boy, Tom didn't know that this magic thing was coming. The
Yeah, I
world does
almost
change.
wonder, it's like, it's funny to think about this because when I go back to the reputation thing, I almost wonder if somebody could fork Btrfs right now, give it a different name, change nothing. All the code is 100% the same, different name. Oh my God, this is the best thing ever. Everybody has to use this thing. And it's just because the reputation doesn't follow it and they just give it a different name. Maybe a different steward is taking it over or something like that. I'm not saying someone should fork Btrfs. If someone wants to do that, they could do that. But I almost wonder if that would probably happen if that were the case, because it's just about the reputation that I think is holding against Btrfs. I think it's fine for the most part. And I plan on diving into it. I don't know when, I don't want to overpromise, but it is on my list to dive into Btrfs and start doing tutorials on that. So
Yeah.
I think 2022 would probably be a safe bet.
Yeah. And, someone I seen in the chat here, and this is a fair enough ask is like, what about if the Synology switched over to ZFS? Could they? I don't know. I really, the devs seem to know it really well. Synology is selling a lot of high end systems. We know because we've delivered a lot of high end systems, Synology, and they've been really reliable, really performance based. The engineers there have done a great job of making all that magic work.
Yeah.
Engineers that are dedicated and building a stable product aren't quick to change. So Synology would keep developing it because dropping in ZFS would be a big development change because, well, all their tooling is built around Btrfs. But that
Right.
being said, you look at something like QNAP. I'm not a fan of QNAP for security reasons. Follow Steve Gibson and look for QNAP for reference on all of them. Not to get too off topic here, but the QNAP has ZFS options. So that's something to think about. There are other NAS companies building it out there, and they didn't always have them. It once again comes back to that Linux compatibility thing. Now that it's Linux, it's going to see out there. But as far as ZFS, and I'm always a firm believer in TrueNAS, but I have reviewed ZFS on like the 45 Drive system. They have their own implementation of ZFS and Linux. You check out 45 Drive's channel. They actually do some nice dives into that. But I think both are going to go for it. Someone said Btrfs. I've always called it Btrfs. I've heard both. I think it's supposed to be Btrfs, but butter always just sounds better to me.
Yeah, I think it's Btrfs. I wonder if that individual said Btrfs as like a remark on my joke about forking it. Call it Btrfs, which is very similar to the original name.
I think Margarine FS. I seen someone suggest that. That seems like an even better.
I can't believe it's not Btrfs.
Yeah. we could just come up with a lot of names here. I can't believe it's
Oh
not
yeah,
Btrfs is a good one.
for sure.
Uh, all right. I think we ran down the list and hopefully we educated a little bit file systems. And if you're really confused at the end of this, just use whatever your OS default is because they've optimized for it. That's why it's a default.
Yep, that's true. Yeah,
That's a
absolutely.
really honest answer. I mean, I think it was, I remember someone said, is there, what should I change at your default? And they, to optimize it, someone said, if there was better defaults, they'd be the defaults. And I was like, that's like the best. Another developer told me that if there's better defaults, why wouldn't I make them the default? And I'm like, yeah, all right.
Yeah, that's true. I
Fine.
think we live in a world where the defaults kind of are out to get us in terms of security because of default password and
Well,
usernames and no updates. I think that our mindset kind of becomes we need to switch away from the defaults because they're bad. That's not really true. Security, yeah. Okay,
Yeah,
it's bad, but
it's
no, when your distribution defaults to it, it's probably fine.
I blame Microsoft because unfortunately, broken by design is almost a default for Microsoft for a lot of their security implementations. So a lot of people, there is a list of things you kind of need to do to lock down the system because they leave, you know, to my knowledge, still the latest version of Windows Server is by default vulnerable to Mimikatz to keep on some backwards compatibility for really old stuff that I think should be something you turn on because why do you have something that old in your network that needs this weird authentication? Fine, turn it on, but don't leave these things on default. So
Right.
I can see both arguments for it because this is something I heard from a development team developing a very popular, well-secured product versus not something Microsoft's like got a lot of things you got to change by default. So there's reasons to ask it.
There really are. I think their firewall, when they implemented that in Windows XP Service Pack 2, all it did was train everyone to hit the yes button to allow everything in. So then everybody thought that just having a firewall was fine while they're just allowing everything in. So I think it kind of hurt the overall mentality of what a firewall is and what it's good for, among other
Yeah.
things.
Yep. Fun stuff. And yeah, we will dive into some other topics for some next shows, but I think we beat this one up. We've covered it all. We've got all as
Yep.
we can possibly eke out of us. I will leave links to Jay's LVM video because that's handy. Do you have video on Lux as well?
I do, but it's in regards to Arch Linux specifically for an
Okay.
Arch Linux installation. So I'm not sure if I'd recommend most people do it, but
Okay.
you can probably use the same commands that I use in there to create a volume.
Yeah. That way, there's at least one thing to think about when you're creating file systems. And ZFS supports this, and with Lux and combined with LVM, like you mentioned, do encrypt everything. I'm a big, huge
Mhm.
fan of encrypting everything. So, because especially laptops, they're extremely easy to wander off and
Yeah.
at the worst time, and you want to make sure everything's encrypted very well. So, no matter what file system you use, setting things up that way is, yeah, protect your bits. That is
Yep.
huge. All right. Thanks for joining, and see you next time. Send questions and comments and everything else on this video, or reach out to us on our website. We got a contact form, and we do read them. So that's how we build our next Q&A episode. Thank you.
Yep. Thank you.